Hi everyone, let's see how we can troubleshoot this Samsung A12s that I received from another shop. If you take a look, you will see that the shields have been removed already and the phone is not powering on. Taking a look at the PCB, I can see that some capacitors have been removed. We are going to find out later in this video if they were removed because the phone is shorting or how. But first, we do what we normally do. We try to check the current reading. You try to check if there is any auto current leakage from the mobile PCB. If there is no current leakage, we check for current trigger. We check the current trigger of the mobile PCB. So I'm going to connect the phone to my DC power supply right now. You can take a look at my DC power supply from there. So I will just connect it here. So when I connect it, we see that reading, that 0.003. That's basically nothing. Even though it was not supposed to read like that, it shows that there is something wrong with the mobile PCB, but it's not a high current leakage, and this should be an integrated circuit fault. So keep in mind that particular reading can be an integrated circuit leakage, or it can be a disconnection of an IC. I've experienced this. There are times that you will see a reading right there, not because there is a short somewhere in a mobile PCB, but because there is a disconnection. But not to conclude things, let's go ahead, troubleshoot this step by step. So I'm going to press the power button. So you can see there is no trigger. When you press, it goes to 4, right? So that's absolutely nothing. That cannot do anything. So from this reading, it shows that the power manager IC is not triggering, and from that reading it shows that the power button is getting voltage, maybe not the complete voltage or something, but this particular reading shows that the power manager IC is not functioning. Either the power manager IC is not getting the supposed voltage to power up, or the power manager IC is not just working. We are going to troubleshoot this step by step. So I will remove the mobile PCB so that we can examine the PCB. So if we take a look, I'm going to use my microscope so that you will see better. So if we take a look at the battery connector, that's the battery connector right there. And we scroll to this other side, you will see that we have one capacitor removed here. I think maybe the capacitor was removed when the person was trying to remove the shield from this corner. I don't know, but because this is not the only capacitor that was removed from this area, I don't think that was the case. So what we are doing, we have to test to know the reason why these capacitors were removed, so that we will know how we can troubleshoot. So we set our multimeter, continuity test mode, test this area, and it's not shorting. So there is no short in the mobile PCB in that section. Let me not see the mobile PCB because we are still checking. Let's go to the battery connector. The reading is okay. Let's turn to the other side. Some capacitors were removed from here. Let's test. And this area is okay. So I don't know why the capacitors were removed, but we will go ahead and check. So this type of problem, I want you to keep in mind that you have to check and confirm if the power manager IC is getting the voltage that it needs to get. So if I want to check this, the first thing that we will have to check, we have to check the VPH section here. We are not looking for a short in a VPH section. We are looking if the VPH is available. You get, so the VBAT gets into the VPH, and if the VPH is not available, which that will mean that the power manager IC it's not getting the input voltage that it needs to be able to trigger and start distributing to other parts of the mobile PCB, and that can be the reason why the phone is not powering on. So we connect, you have to connect the phone to our boot cable, then we check the voltage in the VPH line. We are getting 3.2 in the VPH line. That's bad. So let's see how many volt is getting into the VPH line. There is something wrong here. We have 3.7 set on our DC power supply, so at least it's supposed to give at least 3.6 or that exact 3.7. So we will take a look at our bit mapping to see the input of the charging IC. Let's go to the battery connector. We have this. Okay, click on this other side. See. Okay, if you come back here, you will see that we have the input of the charging IC here. So why am I looking for this input? I want to test to see if that exact 3.7 is getting into this charging IC, because we are getting a dropout voltage right there. That's not the required voltage that the VPH needs, that the power IC needs. So let's go back and test this. So that input VBAT was getting from here. So we have 3.6. That 3.6 is not bad. So this is supposed to give 3.6 here, but we are getting 3.2. If we set the voltage, let's see, 4 volt, and test again, 3.5, 4 volt, 3.5, that's bad. So the standard voltage of your battery is normally 3.7 or 3.8, which means that setting the current here to 3.7 should be able to give a 3.6 or that 3.7 here, but you are not getting that voltage. So this basically means that the charging IC has a problem. That's the first suspect that we have to suspect. The charging IC has a problem, or there is a small current leakage somewhere in a mobile PCB. But the first thing that we have to do, we have to check this charging IC, because it's not acting well. The charging IC oversteps down the voltage, and the voltage that is getting into the power manager IC is not the one that the power manager IC needs to power up. So the main thing that we have to do here, we have to change the charging IC. That's the first thing that we will have to do. I don't know if I have the charging IC. I'm just going to check. I don't have new ICs. I always do swapping, as you guys know. You have been watching my videos, so I'm going to look around if I will get a charging IC for this. Then if I get replaced, then see how everything goes. So after checking, so this is the IC that we are suspecting that is bad. This is the charging IC from the PCB that we are working on, and I have another PCB here. It's the same IC, even though some numbers are different, but the main number is the first one, which is SM5714, right? Take a look at this other one, you will see SM5714. So it's the same. You have to remove this and replace it with this. So we are replacing this IC. You have to remove this IC and put it here, and see if it will give the same reading. If it gives the same reading, that means that there is a minor current leakage somewhere that is dropping down the voltage. So let's go ahead and remove this. So we have to use this tape to protect the CPU from heat. So let's go ahead and remove this IC. We set this to 355. That F40 is okay. We will have to remove the other one from the other PCB and replace this one. Okay, great. So we have this PCB here. We have to remove this IC here carefully because this is the IC that we are going to use. I messed up these components here, but that's okay. This PCB is not working. All we have to do, we need this IC. That's why I'm not that extra careful when removing from a scrap PCB. So we have to clean this IC here. This is okay. So we use our universal stencil quick. So a lot of people are not even able to reball these little ICs using a universal stencil. So I'm using the magnetic mat of my DC power supply that I made a video about a couple of days ago to do this, and I'm doing this so that you can see how useful this is. But I have no problem reballing without that. As you can see, this is the mat. I made a video about this a couple of days ago. You can check that out. So what we have to do here, we clean the IC, clean the solder of the chip. This is what happens when you are reballing with a universal stencil. Remove that, and you have to be careful not to break the IC. Try the other side. You don't have to risk damaging the IC when it's the only IC that we have. That's okay. So now keep the IC aside so that we will clean the other PCB and get the IC installed. Okay, everything is set for installation. Okay, perfect. That's okay. So let's go ahead and replace this IC right now. Okay, after replacing the IC, I will go ahead connect the phone again to my DC power supply so that we can test the main power supply voltage and see if we are getting the correct reading. So we have 3.7 on our DC power supply. That's okay. Great. So you see now we are getting 3.6 into the charging IC, and we are getting 3.6 in the VPH line. So if I increase it to 4, you will see increase it to 4, you will see the voltage that we are getting. So that's okay. If the angels come for me, I will tell them no. So we connect the power button because we have to check if we are getting a trigger and if the phone is working or not. But yeah, let's go ahead and test this. This phone seems to be on, but the screen is not displaying here. But this screen is a new screen. I don't know if it was supposed to be working. You're getting a correct reading there. Like I said, the phone is actually powering on. From my DC power supply, you could tell. If I connect it to my charger here, listen to the sound. Are you getting that? So I thought that the screen of this mobile phone might not be working even though it's a new screen, right? But after taking a good look at the mobile PCB, I was like, I just have to send the phone to the technician so that he will test a different screen. I don't change screens, so I don't have a screen to test. And yeah, just taking a look at the PCB, I noticed something. The display IC is not available. The technician who gave me the phone said that the customer gave him the phone saying it's from another technician also. So that first technician seems to be the one who removed the capacitors and also the IC. I will put the phone under my microscope so that you will see. And also I just want to show the other part that we removed the charging IC from. The display IC is also available, so we will just remove this display IC from here, transfer it to this PCB and see. But first let me show you what I'm talking about. If you take a look here, you will see that the display IC was removed. The display IC was removed. Seems like the solder is still here. We still have the solder here. So I'm just testing to see if there is any pin without the solder, because with this solder here I can just remove the IC from the other PCB and clean the IC, then yeah, just mount it here without even doing reballing, without even remaking the solder with my stencil. You go ahead then remove the IC from the other PCB. Yeah, this IC should work. I don't know, but I think this IC is supposed to work. So this is the display IC. Now we have the IC of the PCB. So if I go to my bit mapping software, if I go to my bit mapping software from here, you will see that this is the IC that we are talking about. So as you can see, these are the two capacitors that were removed from this area, and this is the missing IC. Let's just see the position in which we will have to position the IC. So we have the mat side and the other side. So the mat side is supposed to be here. And you have to make sure we protect the CPU at all costs. That's why that actually change the look of this. Apply a little bit of paste. So like I said, the reason why I was taking a look at the pins here was to see if the solder is still available in the pins and if they are all equal. So they were all equal. That's why I haven't reballed the IC with my stencil. Okay, I think that should be okay. So after putting the IC, the display IC, there is image but no backlight. So let's test. We're supposed to get 24 volt here when the phone is on, and just from the diode reading you can see we are getting 56 ohm reading right there. So that's very low. There is no way you can get that high output here with such a low ohm reading. So I don't know if it's the IC that it's not okay. Yeah, it's supposed to be getting a very high reading here, but there is no high reading. So it could be the diode or the IC. But if it was the diode, we will be getting a low current here. But yeah, I don't know. We will test and see. We're getting a very low reading there. Okay. So what we are going to do, we will remove the diode and test. We will remove the diode and test the section again, then see if we are still getting that little current that we are getting there. We are still getting that little ohm reading there. Okay, let's go ahead and check the diode reading of this. So we are still getting a small reading there, which means that the diode that we removed here is okay. The diode that we removed there is okay. We will have to mount the diode back. We have confirmed that the problem is not the diode, because after removing the diode we are still getting that low ohm reading. The display IC should be the only problem here, so we have to replace that. I don't have the IC right now, but I'm still with the phone. Anytime that I get the IC, change the display IC, I'm going to upload a video, but that should be the only problem with the phone right now. So thank you for watching. Subscribe, follow for more videos, and yeah, don't forget to get my courses with a 60% discount right now.